Hello friends. In the world of soft computing, we often come across three terms that is called set, crisp set and fuzzy set. By the end of this particular video, you will have a clear understanding about the context in which these three terms are used often. In mathematics, we have come across set, which is just going to hold information about certain elements. That's it. Like over here in a pictorial form, I have represented that. Consider these are 5 different students. So I'm going to hold the information. Well, over here I have made use of list, although Python has a data type called set. But the problem with set is that it doesn't maintain the insertion order, and I have to run the program. So for that reason, insertion order is important. Otherwise, I could have written over here set, and this whole thing would have been very same. But just to execute this entire program, here the list, consider this to be like a set, and consider these elements to be unique, because we know inside set elements are unique. Okay, so I have a student list, or consider it like a student set where all these 5 students are there, which is just holding the information. That's it, nothing more than that. But what I want is that along with the student, I want to associate their heights. What I want, not just only student information, but at the same time the height of the respective student I also want to associate. And for that reason, what I'm doing is that I'm creating a dictionary over here. So corresponding are the student name and the respective heights in the form of centimeters. Consider this. I've written this. Okay, that's great. And then if I print it, this information will be shown in the terminal. Okay, so far so good. And that's all about set. Simply storing information. No decision making is coming from the set representation. But I move to the crisp set, and once we move to the crisp set, over here we have a binary scenario. What is a binary scenario? The binary scenario means, is the student height is greater than 170 centimeter? Well, if it is so, then I will say it's 1. Otherwise I will say 0. Okay, so there is a binary membership function involved. Yes, this membership function is going to tell me whether the height of the student is greater than 170 centimeter or not. That's what I'm going to put forward. An extra information I'm going to associate in context to crisp set, and that is a membership in the form of binary. So let's see how am I achieving this right over here. So what I have got over here is that I have my list, a new list I've created. Sorry, this particular list, I'm just going to pass on information of those students which actually height is greater than 170. That's all. It will not hold all the 5 student information. We're running a loop over here, so it picks up the first student name, that is A, and store inside this particular student reference. And now I just want to pick up the value. For that reason, I've said height, and I'm passing this A as a key, and I'm going to get a value as 150. Is that greater than 170? The answer is no. So it's not included in the list of crisp set. Same happens for B, which is 160, and it is not true, it's not included. While in case of C, D and E, 170, 180 and 190, all these 3 information are been true, and they are the part of the crisp set list. So this particular list is just going to hold only 3 student information who hold height equal or above 170. Just that only, nothing more than that. Okay, but what I need is something called membership value, and for that reason I am now going to run this particular loop. Again, the same thing I'm doing it. This time I'm not just only checking the height, but at the same time I'm also associating the boolean value 1 if it is true. Otherwise it will be 0. So in case of student A, which condition is false, it will be 0. In case of B, the condition is false, it will be 0. While in case of C, D and E respectively, the height is true, and it is written in one single statement. Since the height is true, I will be associating 1, and this 1 will be assigned to membership variable. But in case of A and B, we are going to get 0 assigned to membership variable, and the corresponding membership value in the form of binary will be represented. Why don't I run the program to see what the output we are getting? So let me click on the terminal over here, and the output comes right in front of us. Just wait for a while, and here it goes. So these are all the 5 students which you can see because of this particular print statement. These were the three students whose condition got matched, and that's what got printed because of this print statement. And these are the student information whose corresponding membership value is shown right over here, and that's what called crisp set. So crisp set is showing us the binary membership value. But trust me, in real life only binary information is not sufficient, and for that reason we have to move to the third type, that is called fuzzy set. So when we are working on fuzzy set, I have to write a membership function which will show me the gradual progress. Got it? In case of crisp set, I wrote a membership function that was holding the value of context to 0 and 1 only, but I know also the progress in which it is working, how much the growth is. So for that reason we have to write a membership function, and that's what is been represented mu. So mu is the membership function that we are going to write, and in that membership function I'm going to put individual heights, and then we'll see the progress what we are going to get, and that's how this mu representation comes in the form of membership function. Okay, and gradually we will see how tall the students are. So gradual progress is going to happen. So in case of the first student there would be no progress. Why? Because 150 is the first student height. 150 minus 150 divided by 190 minus 150, that means 40. So 0 divided by 40 will not get any progress. Then we pick up the next student, 160. 160 minus 150 is 10 divided by 40. We are getting a membership value of 0.25. Similarly, 170 divided by 150, 170 minus 150 divided by 190 minus 150, we are getting a membership value of 0.5 right over here. Previously we got 0.25, and now we are getting 0.5. And then in case of 180 we are getting a membership value of 0.75, and finally in case of the student whose height is 190, so 190 minus 150 is 40 divided by 40, we are getting the height of, the membership value of 1, and hence we are seeing a linear progression. So for that reason we have to come up with a function, and we are going for a linear function right over here, and this is the linear function in context to the membership of this fuzzy set. So we are seeing a gradual progress, and that is the reason why we need to work on fuzzy set, because we just don't want to settle down with the binary input of 0 or 1. Rather we also need to see the gradual increment that is taking place. So now let me uncomment this entire section of fuzzy set, which will show me how exactly I'm writing this linear function. So over here also I'm going to come up with a new reference which is in the form of dictionary, because I have to store the membership value this time in the form of a value in between 0 and 1. That's what we have to store it. So here what I'm doing is that I'm giving a call to again the same student. So I picked up the first student A, stored over here, and then I'm giving a call to a function which I've written over here by the name called fuzzy membership function. So height, when I pass this particular A as a key, I got the height of 150. So that 150 I'm passing it over here, and then I'm going for what? 150 minus 150, that will be 0, divided by 190 minus 150, that is 40. So 0 divided by 40 will not get any stuff, and we are going to round off to 2 place decimal. So let me clear the screen and let me run the program again to show you how exactly the graph which you saw will come right over here. So let me run the program now, and let's click the run button over here to show me how exactly the fuzzy is going to work. So in this way the fuzzy is going to iterate. See, here it's showing the student A has got a height of 150. My function has given me 0, while the student B has a height of 160. So 160 minus 150 divided by 190 minus 150, we are getting 0.25. Similarly for 170 we are getting 0.5, for 180 we are getting 0.75, and finally for 190 we are getting 1. So we are going to come across this membership value, and for that reason we have to write this particular fuzzy membership function is what we are going to come across as the thing iterates. So each value which you are getting over here, that is first 0.0, gets stored inside this particular dictionary. So the dictionary key is A has a membership value of this. again it goes up, it picks up the next student which is called B, and its corresponding height has been passed over here, that is 160. So 160 minus 150 is 10 divided by 40, we are going to get 0.25, and that has been rounded off to 2-place decimal, and after that it's been returned, and the return value will be assigned as a value for that particular key, that is called B. The student name is B, so the key will be B in this particular dictionary. In the same way, it goes up once again and picks up the student whose name is C, and the corresponding height is 170. So the height is 170 passed over here, so 170 minus 150 is 20 divided by 40, and it would be rounded off to 2-place decimal, and finally we are getting 0.5, and that 0.5 will be assigned as a value for this particular key, which is called C, and C will have the value as 0.5. And this way this particular iteration takes 5 times, and finally we got a fuzzy membership function which is showing me the gradual progress, and that's what we are seeing in the graphical format, that how exactly the fuzzy membership function is gradually showing me the how tall. It's showing me the degree of tall, being how tall it is, been showing right over here. And that's the difference between the crisp set, which was just showing me the binary, that whether it's tall or not, but it was not showing the gradual progress, and that's what we saw right over here. And finally this particular dictionary is what I'm printing with the help of the dot item, that shows me the value in form of key and value, and that's how we are going to get the ultimate fuzzy set. I believe after watching this particular video, this particular 3 terms is now crystal clear that how exactly the term set, crisp set and fuzzy set, that shows me the fuzzy logic for building a membership function, and from there we see the gradual progress in context to every input of that particular fuzzy set has been shown over here. And this particular video I believe will be helpful for you, those who want to have a good understanding in the field of Python as well as in the soft computing. Okay, so that's all from this video presentation. In fact, there are going to be more videos in context to this. This is the mere beginning of the journey in the field of soft computing. See you soon. Bye bye. Take care.